So can you all see my screen?
Yes, sir.
Yes,
Okay.
sir.
So what are the topics present in unit number 5?
FSM Mealy more.
Okay. And in this we have designed different kinds of finite state machine of different sizes.
Partition minimization technique.
Okay. What is partition minimization technique? What is reduced state table and minimized state table?
In reduced state table, we delete and replace, sir. In minimized state table, we
In
only
minimized
delete the
only, you have to delete, no replacement.
Okay. So the next concept that is left in unit number 5 is ASM, which is Algorithmic State Machines. So here you can understand this particular topic once if you know how to draw the state diagrams of Mealy finite state machine and Moore finite state machine. So what is the difference between Mealy and what is Moore? Yes,
Mealy
anyone?
depends
In
on
Mealy,
present state and present input. More depends on only present state.
Okay. In Mealy, output depends upon both present input as well as present state, whereas in case of Moore, it depends only upon present state. So the next concept that is left is algorithmic state machine. So let us see some of the basic definitions in order to understand this one. So what is data? So data is nothing but discrete elements of information that are manipulated to perform arithmetic, logic, and shifting operations. What are arithmetic operations?
addition,
Addition,
subtraction,
Addition,
multiplication.
Next, what are logical?
logic and logic or.
Logic or.
Okay, and or not. If you want, you can include the remaining
Not.
all the NAND or XOR and XNOR. Next, what are shiftings?
Right shift, left shift,
Left shift.
Before that, arithmetic. Next one is logical. Again, in arithmetical, there will be arithmetic left shift and arithmetic right shift. Similarly, in logical, logical left shift followed by logical right shift. Okay, so these are the different operations which I can perform if I have some amount of data, so that I can do data processing task. So what is the difference between arithmetic right shift and logical right shift? Both are same or any difference?
Both are different.
Both are different. How? Tell me for logical right shift. I'll give some random sequence of size 4-bit. So let me take for 1010. Tell me the answer after performing logical right shift by 1-bit position. What is flip-flop? What is flip-flop and what is register? Flip-flop is nothing but it is a 1-bit storage element. Then what about register? Register is nothing but group of flip-flops. So here, how many registers I am using or else how many flip-flops I am using in 1010. So here you are storing 4 bits of information. So you can call this one as 4-bit register. So here how many flip-flops I am using? 4 flip-flops.
flops.
So register is nothing but simply group of flip-flops. Now shift this one by 1-bit position towards right side position. Shift it 1 bit right.
1101.
So this one comes here 1. Here it will be 0. This one will be 1. What about most significant bit? Should I fill it with 0 or 1? This should be 0. Now if you take the equivalent of 1010 in terms of decimal, what is the decimal equivalent of 1010? Decimal equivalent of 1010.
5, sir.
For the question you tell me.
10.
For 8421.
10.
It is 10. After shifting,
5.
5.
it is 10.
5.
So what is happening here? Divide by 2. Okay, so logical right shift is nothing but you are dividing it by 2. Now tell me the answer for arithmetic right shift. Same question. Now I want arithmetic right shift. Same sequence 1010 only. Tell me arithmetic right shift shifted by 1 bit position. Again I am using a register which is of size 4 bit. So here the important thing is first most significant bit should be preserved as it is, and again most significant bit should be shift right by 1 bit position. So 1 comes here and here it will be 0, this one will be 1. If you take the equivalent, this one will be 10. And what is the equivalent of 1101?
13.
It is 13.
Seven, sir.
This is a difference between arithmetic right shift and logical right shift. Now, similarly, let me do for logical left as well as arithmetic left. One zero shifted 1 bit towards left. Left shift by 1 bit position. So this 1 will go out. This 0 comes here. Here it will be 1. This is 0. What about least significant bit? It should be filled with 0 or 1.
0.
It should be filled with 0. So if you take the equivalent, this one will be 10 and this one will be 4.
4.
Now do it for
4,
arithmetic.
sir.
Arithmetic left shift. Will there be any difference or same?
1 will be shifted
Same.
to the second position.
So tell me the final answer.
Same, sir.
0, 1, 0.
This one will be same. So there is no difference between logical left shift and arithmetic left shift, but there is a difference between logical right and arithmetic right. Remember this point. So logical right as well as arithmetic right, both are different. Here important thing is most significant bit should be preserved and after that it should be shift right by 1 bit position, whereas that concept is not applicable for arithmetic left shift.
Sir,
So
one
these
more
are the
time when we
different
explain the right shift, sir.
Which right shift you want? Arithmetic or logical?
Logical right.
You want logical right. So no difference here. The concept is same only here. Only in arithmetic right shift it will be different. Whereas in logical right shift, only we will shift it 1 bit by right. 1, here comes 0 and here it will be 1. Whereas most significant bit should be filled with 0. It should be filled with 0. Most significant bit should always be filled with 0 in logical right shift.
0, sir.
In everything it will be 0. If it is blank, it should be filled with 0. Whereas the same concept if I want to perform with arithmetic. Tell me the difference. If this is arithmetic now.
1 should be preserved.
Correct. This 1 should be preserved and again this 1 should be shifted right by 1 bit. This is the only difference. Remaining 3 are almost same. So try to remember this.
Same applies for left shift also, no, sir?
Yes, left is same. Logical and arithmetic both are same. Only in arithmetic right shift the concept is a bit different. Remember here most significant will be preserved as it is and after that it will be shifted right by 1 bit position. If you are having doubts, try to perform this one by using different kinds of equivalents. Next, what is the purpose of control information? So control information provides command signals that supervise the various operations in the data section in order to accomplish the desired data processing task. So just now we have seen the different kinds of data processing tasks are. It can be either arithmetic, logical or else shifting. So What are the two distinct parts of the logic design of a digital system? So can someone read this?
The logic design of a digital system can be divided into two parts. One is concerned with design of the digital circuit that perform the data processing operation. The other part is concerned with the design of the control circuit that determine the sequence in which the various operations are performed.
Okay, so there are two different circuits will be there. One is for controlling part and another is nothing but data processing, which is nothing but data path. So this control circuit will give some commands so that based upon these commands, data processing operations will be performed. So in order to understand this one, you need to see the logic diagram. So this will be the logic diagram. It contains control logic followed by data path. So this control logic is used to give the commands. Means what kind of operation should be performed here. Means what kind of data processing task should be performed will be intimated by means of this control logic. Whereas the inputs for this control logic are nothing but external inputs, and it will give some commands followed by data path also contains some external inputs. So based upon that, different kinds of operations will be performed in data path. It can be either arithmetic, it can be logic, or else it can be shifting. So just remember there are two kinds of logics. One is control logic, next one is data path. Next, what is an algorithm? An algorithm is a finite number of procedural steps that specify how to obtain a solution to a problem. So simply algorithm is nothing but a step-by-step procedure. Next, what does ASM mean? ASM is nothing but algorithmic state machine, which is nothing but synchronous sequential circuit. What is synchronous sequential circuit? What is synchronous and what is sequential circuit?
Different clocks are.
Synchronous means clock is given to each flip-flop, sir.
Synchronous means clock should be given to each and every flip-flop or only for the first one?
Each and
Each
every
and every flip-flop.
Correct. Each and every flip-flop should be given clock. Then what is sequential circuit?
Output is depends on present input.
Output depends upon only present input
and present state.
Only present input and present state. So combinational circuit followed by a memory element is called a sequential. You need to remember this particular diagram if it is a sequential circuit. So it contains some external inputs and you'll get output, and that output will be stored in the memory, and again it will be given back as the feedback. So here this is called as present input, this is present output, this is present state, this is next state. So complete this diagram put together is called as a sequential circuit. Whereas synchronous is nothing but we are applying clock for each and every flip-flop. Next, ASM chart. So an ASM chart is a flowchart used to describe the clocked sequential circuit. It is a hardware algorithm which specifies a control sequence and data path task in a digital system. Just now I told you, so control logic will give the commands, and based upon that commands, the data processing operations will be performed. Hardware algorithm is a step-by-step procedure to implement the desired task with selected components. So this question is important for 2 marks. What are the different kinds of boxes or elements are there? So generally there are 3 types of elements. One is state box, next one is decision box, and third one is conditional output box. First one is state, second one is decision, and the third one is conditional output box. So while drawing ASM chart, we need to make use of these 3 elements. ASM chart versus conventional flowchart. Yes, someone read this.
Sir, should I read?
Yes.
The ASM chart is an alternate way for describing FSM and is similar to conventional flowchart. A conventional flowchart describes the sequence of procedural steps and decision paths for an algorithm without any concern for the timing relationship. The ASM chart, on the other hand, describes the sequence of events as well as the timing relationship between the state of the sequence control and the event that occur while going from one state to the next state after each clock edge. In ASM chart, every ASM block is considered as one unit, whereas in the flowchart, every operation block is considered as separate unit. A conventional flowchart uses only 2 elements, state box, decision box, whereas ASM uses 3 elements, state box, decision box, conditional output box.
Right. So ASM chart It is nothing but an alternative way for describing finite state machine. So what is finite state machine? What is finite state machine? We have detected multiple sequences also. By using Mealy and more, we have detected more number of sequences. The alternative way of doing this one is ASM. So when should I use ASM and when should I use FSM? Suppose if input and output combinations are limited, then we can go for finite state machines. Suppose if the state diagram is very lengthy, then there might be a problem with finite state machine. So in order to overcome that, we'll go for algorithmic state machine. So simply you need to remember one point is ASM chart. So in finite state machine, what is the first step that you are doing? Suppose if you want to design it using Mealy, what is the first step that you are doing? State diagram or state table?
State diagram.
So you will draw the state diagram. Now based upon the state diagram only, we will draw the ASM chart. Almost both are same, but in finite state machines it is called as state diagram. In algorithmic state machine it is called as ASM chart. Just by seeing the state diagram only, we will draw this particular ASM chart by using these three elements, which are state box, decision box and conditional output box. This is the only important thing that you need to remember. And next, if it is conventional flowchart, so timing relationship is neglected. Whereas in case of ASM, sequence of events followed by the timing relations are considered. And in conventional flowcharts, only these two boxes are used, whereas in ASM, these three boxes will be used. That is state box, decision box and conditional output box. So conditional output box is only used for Mealy finite state machines or else Mealy ASM. This is not used for more. Remember this point. Conditional output box is not used for more. It is used only for Mealy. So you'll get clarity on this if we do some examples. So algorithmic state machine. So let me solve some problems so that it will be a bit clarity for you. So before that, see the components of algorithmic state machines. There are three components or three elements, which are state box, decision box and conditional output box. This conditional output box will be used only for Mealy but not for more. This is one important thing. Now let us see what is state box. So state box will be represented like this, which is nothing but a rectangular box. Here on the left hand side, state should be written. So this is nothing but state A. And this is called as state assignment, means the equivalent that we are assigning. This is called as state assignment. And it contains some entry point followed by exit point. And Z. What is Z? Is it input or output?
Output.
So Z is nothing but output. Whereas X is nothing but
Input.
So state box is nothing but, simply remember this diagram, which is nothing but a rectangular box, and this is the format. So A should be written outside, which is nothing but the state, and this is nothing but the state equivalent. It contains some entry point and exit point, whereas output will be indicated within this particular box. Decision box. So decision box is nothing but a rhombus box. For this, if I give some amount of input, and it will see the conditions whether it is true or false. So always 1 means true and 0 means false. This is called as state box. Last one is nothing but conditional output box. This conditional output box will be used only for Mealy, not for more. List the condition outputs here, and it contains some entry point followed by some exit point. So just remember these three boxes so that we can start drawing the ASM charts. So this question will come for 2 marks. What are the different components of ASM chart? Means you need to write all the state, decision box followed by conditional output box. Conditional output box is nothing but Mealy, whereas decision box is nothing but the rhombus box, and state box is nothing but a rectangular box. So what is this? Is it Mealy or more?
Mealy.
This is called as Mealy. Why? Because we are indicating input by output format. So this is X by Z. So I've taken some random state. What is this? State table or state diagram?
State diagram.
Also called as state graph. Now ASM chart. This is nothing but ASM chart. So blindly by seeing that state diagram only, we need to draw this ASM chart. So in order to draw this ASM chart, 3 boxes are needed. State box. Next one is decision box. Third one. Should I use third box or not for this, Mealy?
You have to use.
No, sir.
Should use.
You have to use. Conditional output box should be used. So see here. How many circles are there?
3.
3. Here circle
3.
indicates.
State.
So draw 3 rectangular box. 1, 2, and 3. Done. Next. See what is the equivalent. This is H0. This is S1. This is H2. So write it outside the box at left hand side. S0, S1, and H2. Now just by seeing the input and output combinations, we need to do all these cases. So see, for this H0, if I am giving input as 0, so first this should be given to the rhombus box, which is nothing but a decision box. If it is 0, where it is going?
S0.
For S0, if I am giving input as 0, it is going to H0 only. Next, for H0, if I am giving 1, where it is going?
S1.
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 So see here, when I give input as 0, again it is going to H0. If I give 1, it is going to S1. So that's what I've indicated it here. Next, am I getting any output here? Here
No,
output
sir.
is 0. So in Mealy, only conditional box should be used whenever there is output is 1. So here as I'm getting output is equal to 0, so no need of using conditional output box. So this is the first step. Next, tell me for S1. For S1, when I'm applying 0, where it is going?
S2.
It is going to S2. Okay. If I apply 1,
S1.
S1 only.
so the same thing you should indicate here. So for S1, draw one decision box. If it is 0, it is going to S2. If it is 1, it is going to S1 here. Okay. If it is 0, it is going to S2. If it is 1, it is going to S1. Next, tell me for H2.
For
If
0, it is going
it is
to
going to S0. S0.
S1.
H1.
Is going to S1.
If
For 1, it is going to S1.
going to S1.
So for H2, draw one decision box. If it is 0, it should go to
Going to S0.
H0. If it is 1,
It is going to S1.
S1.
it is going to S1. But why I'm using this box? Can anyone tell me?
Output is obtained.
Output.
Correct. Here I'm getting output. For H2, if I apply 1, it is going to S1. At the same time, I am getting output as 1. So conditional output box should be used only once when I am getting output as 1. So when I'm giving 1, I'm getting output as 1. If you want, you can write like this also, z is equal to 1. And after that, it should be given to S1.
S1.
So this is the only difference that you need to remember. So next your task will be, so till now I've given you some assignment of drawing Mealy and more finite state machines. Now for the same sequence, you have to draw this ASM charts also. Now let me do it for more. Now identify the circuit. Mealy or more?
Mealy.
Mealy. So how many state boxes, how many decision boxes, and how many conditional output boxes I have to use?
3
Just
state
by
box.
Three state boxes.
3 state box. How many decision?
3.
1 conditional box.
3
decision.
decision.
3 decision.
1 condition.
1 conditional block. Why 1 conditional?
2.
Who are they?
How many outputs are there? Here I am getting output as 1. Here also I am getting output.
3, sir. 3.
So 3 conditional output.
Conditional output.
So first state boxes. So 1, 2, and 3. Next, for H0, if I am applying 0, it is again going to H0.
S0.
So mention this arrows correctly. If I am giving 1, it is going to
S1.
S1.
followed by.
And output is 1.
So it should be passed through the
Output. Z.
which box? Conditional output box.
Conditional output box.
So you can call this as oval shaped box or else rectangular box with rounded corners. Rectangular box with rounded corners. Anything is fine. Either you can call it as oval shaped or else rectangular box with rounded corners. Okay, done with S0. Tell me for S1 now.
S1, if it is
If we apply
0, it's going to
it near
S1
S,
and giving
if
output
it
1.
going to S2.
Output
If
as
it is
1,
1,
it is going to
it is going to S2.
S2. Done. Tell me for S2.
S2, if it is 0, it is going to S. If it is 1,
One
it is going to S0, leaving output 1.
Done. So just if you know this particular state diagram, blindly you can draw the ASM chart. So be perfect in drawing all these particular state diagrams. Now what is this? In exam he won't give you the state diagrams. He will give you the sequence. For that particular sequence you need to draw the state diagram, and by seeing that state diagram you need to draw the ASM chart. So let me do it for more finite state machine. So how many states are there here?
4.
4.
4 states are there. What is the difference between Mealy and Moore in terms of diagram?
In
One
more
extra sheet in more.
Output is within the circle.
Okay.
And more will have
And
one
one
extra.
sheet.
It will have one extra shade followed by output should be indicated within the circle. Here the circle is nothing but state.
State.
So how many state boxes I have to draw?
4.
So 4 state box. How many conditional? Conditional output box.
1.
Or else
One,
decision box.
Sir.
sir.
1, sir.
One.
4
conditional
decision
output
box.
Okay, 4 decision box. What about
One
conditional output?
One condition.
One conditional.
Already I
Sir,
told you not to
conditional
use
not there.
conditional box for more. In more, no conditional box concept. Why?
Output is in the state.
Correct. Output is indicated within the circle. That is nothing but state. So that's the reason no conditional output box. Only conditional output box should be used for Mealy, not for more. So S0, S1, S2, S3. So this is S0, S1, S2, and this is S3. It should be written outside at left hand side. Next, it contains some entry point.
It is going to 0.
Okay, if it is 0, it is going to
0.
S0.
Not.
S
If
not.
it is 1,
If it is 1, it is going to
One.
S1.
okay. Next, tell me for S1.
If it
For
is
0,
0,
If 0, it is going to S2.
going to S2.
For 1,
S1.
Yes, one.
S1 only, sir.
okay, it is going to S1. Now tell me for S2.
If it is 0, it is going to S2. If it is 1, it is going to
If it is
S3.
1, it is going to S3.
0
If
it's
it
not,
is
sir.
0, it is going to
S2.
Yes,
It's
not.
not.
No.
Acha, okay. If it is 0, it is going to S0.
S
If it is
not.
1,
This one
It is
going to
going
S2.
to S3.
S3.
okay. For 0, it is going to S0, and for 1, it is going to S3. Correct. Next, tell me for last case S3.
If it is 0,
It is
it is
0,
going
0,
to
it is going to
S2.
S2.
If
If
it
it
is
is
1,
1, it is going to
to
S1.
S1.
Okay. If it is 0, it is going to S0. If it is 1, it is going to.
If it is 0, it is going to S2, sir.
And where should I indicate output now? Where should I indicate output?
S3.
In the last.
S3.
So if you observe here, in the last state box only I am writing as Z, indicates that it is Z is equal to 1. Whereas in the remaining boxes it is blank. Here this blank indicates Z is equal to 0. If you observe in the S3 state only I am getting output as 1. So that's the reason I mentioned here as Z, which indicates Z is equal to 1. You can write like this also. Z is equal to 1. So only one concept that you need to remember, in more finite state machine, there is no concept of conditional output box. Only first two boxes are enough. So this much is enough in order to understand ASM chart. Draw ASM chart for 1010 sequence. So what will you do? You tell me now. 17B. Draw ASM chart for 1. First draw
State diagram.
state diagram.
Mealy
Which
or
one you
more.
Mealy or more? Okay, it's your wish. You can go either with Mealy or more. Next,
Next, based on the state diagram, draw
draw
conditional
ASM chart.
output box.
We have to draw.
Draw ASM chart based upon the state diagram. If it is Mealy, make use of 3 boxes. If it is more, only first 2 boxes.
Two box.
Done. So this much is enough. So that's the reason be perfect with latches first. So if you understand latches only, you will know about flip-flops. After flip-flops, we have seen flip-flop conversions. After this, we have understood different kinds of counters. Again, in counters, we have seen how many types? We have seen synchronous, asynchronous. Again, in this, up, down, as well as mod. If you understand all this, you will do finite state machines. And this Mealy and more will be there. And if you know this Mealy and more only, you will understand this. So, if you want to study, read unit number 1 and 2 continuously. First, complete unit number 1, after that, unit number 2. If you want to start unit number 4 directly, start 4 and after that, it should be 5. So, this is the order. And third unit is something which is unique. Directly also, if you want, you can start. Whereas, if you want to start 1 and 2, first go with 1, after that 2, and it is first, 4th, next it should be 5th. Done. So let me ask you now the counters. Rule number 1,